Hello, welcome back to Advent of Code in my own programming language. This is going to be day 5. Hello, I'm a bot. Same bro. Vladik Supercock. Nice name. Welcome. Hello, Penguin. Alright, so we just open the VS Code here, and then we wait, did I open cast? I mean, sure, let's open the... And then we open the Advent of Code, and we read it and we solve it. How difficult is today's Advent of Code? Who knows? But what do we have here? The database operates on ingredient IDs. It contains on a list of fresh ingredient ID ranges, so we have some ranges here. A blank line and a list of available ingredient IDs. Okay, so we have a list of ranges, blank line, and then a list of available IDs, right? The fresh ID ranges are inclusive. Range 35s, and then the ingredients IDs, these are all fresh. The ranges can also overlap ingredient IDs fresh if it is in any range. The L's are trying to determine which of the available ingredient IDs are fresh. So basically we need to go over all of these things and determining if they belong to one of the ranges, right? And if they do, then we want to yeah, we just want to see how many of these are in the ranges. That's all. Sounds easy. I guess it depends a little bit on the size of the input, right? So let's create day 5, not day 5. Copy this, create example txt. The example is this thing, and then the actual puzzle input is this. Day 5 input txt. All right. Let's take a look at the input first. How many ranges do we have? We have 200 ranges. We have 200 ranges, and we have 1,000 numbers. So if we do it the brute force way, then it is going to be 1,000 times 200. 200,000. We should be really fast still. So maybe like we don't even try anything fancy here. There's probably going to be something fancy needed maybe for the part 2. I don't know. But yeah. I need to also add day 5 to the roots of the workspace. Like so. All right. So we have the input, and then I need to find the empty line, right? Okay. Yeah. Let's just do string lines input line. So for every line, we want to say that if length line is 0, so it's an empty line, then this is like the this is this one, right? Or potentially something in the end if we have empty lines there. All right, yeah. So we should have ranges, right? So ranges is list create, and then we have available IDs, right? IDs is another list create, and then we say that parsing ranges is true. So if we see the empty line, we will say that parsing ranges is false now. So we stop parsing the ranges, right? So then we do, yeah. And then we do otherwise. If I am parsing ranges, then we do one thing, otherwise we do something else. Hello, Nigel. Why an empty line and not an end of file? Because that's the input. They show us the empty line here, right? These ranges and the things are separated by an empty line. That's the format that they give us. I mean, I can also detect if the line just contains the dash or not. Like, that's another way to read it. It's like, whatever. Doesn't matter. All right, so if I'm parsing ranges, then I need to do string split. I need to split once. Do I have split once function? I don't remember. Split once line with a dash, right? Let's see if I actually have it or not. Nope, my LSP crashes. One day I will make the LSP actually work. No, split once actually is the function. Okay, right. Yeah. Okay, so we have split once, and this is going to be like start and end, right? And then we say that also start is start int 32, no, string 2 int 32, and then we do the same for the end. And we say ranges, ranges, list push back, ranges, start, and right. Otherwise, we just say that ID is string to int 32 line, right? And then we say IDs. We don't have methods yet. List push back. IDs ID. There we go. So this should be just me reading the input. Done, right? So let's do dbg print ranges, dbg print. I mean, let's do dbg print, you know, ranges and IDs like this. I should look into why my LSP is leaking memory. A little annoying. Day 5. Okay, let's see. So I read the input ranges is... this doesn't work. Yeah, I need to like... Yeah, it does not work like this. Because we have trips under the hood here. Anyway, I think everything was properly read, so yeah, let's just ignore this. Put txt. Input txt though stopped. Why? Could not parse int32. Oh, okay, so now we have int64s again. Nice. Hello Msoft. And to make sure that these are int64s. So I guess all of the ranges are int64s. And the IDs are also int64s. Okay, that works. Okay. Not there yet. I'm contemplating if I should try to solve it in an XLT form day 1. Is my language compiler interpreted or JIT? For now it's interpreted, but it's going to be both JITted and compiled. eventually. Like, ideally, that's the goal. But my language is not ready yet. It's a work in progress. I'm going to be improving the language today. Also, and to use LLVM or write yourself. LLVM is a very long-term plan. So before LLVM, there's going to be a lot of other things that are happening.
Hello, Betseg.
And before LLVM, like I will go for something simpler. LLVM. I mean, I never tried LLVM, so maybe it's not like that difficult. But I heard that it's difficult, so we go for something simpler. There are other alternatives to LLVM, right? I think one of the alternatives is generating the assembly myself, I guess. I'm not sure if I'm going for that route or going for QBE or crane lift or the other options. Also, LLVM is slow, which is why we want it. Like, LLVM is slow, but we want LLVM to be used to produce the efficient binaries, right? So it should be an option eventually when I go for the speed of the language. Right now, I'm not going for speed of the language. I'm just making the language work first. Forgive me, but why write in another language when the perfect language already exists? What's the perfect language in your opinion? How about Betseg? I think that the perfect language doesn't exist, which is why I'm making my own programming language. Assembly is a perfect language. So you are writing everything in assembly, right? Is that right? Rust? No, Rust is not perfect. Rust is definitely not perfect. Rust is good, but it's not perfect. I intend to make a language that's better than Rust. Yes. Okay. What do I need to do? We need to solve this thing, right? So we just go over all of the ranges, right? So we say answer is 0, and then we do at least iterate IDs, ID, and then we say that, and we say, I think there will be the definitely perfect language, but some are better at certain things. Yeah, but there can be, like, I don't know. I don't really like that, like, like the reason there are languages that are better at certain things is because, because like other languages did not think about making it being good for that certain thing for which the other language is better, right? But what if we actually make a language that's good for all the things? You know? That's why all the languages suck. They did not think about everything. So what if we think about everything? But Mojo is very interesting, if they ever finish it. Yeah. Mojo is interesting, I agree. Well, then I will have to learn it then. My language? I mean, it's very far from being done. Maybe I will also never finish it, just like Mojo. Although Mojo, the Mojo, they do have something working right now. It's already like interesting, I think, what they currently have. I briefly looked at that. Thinking about everything is hard, sadly. Well, I mean, we can at least think about everything that that I have touched, I guess, right? So like I know what I have tried to do, and I know that there is no language that is good enough for all of the things that I want to do, right? So I should at least go for that, right? I should maybe like going for something that I don't even know that I want is going to be difficult, yes. You're interested how big my compiler is? I said, like I said, we have the interpreter right now. We don't. I don't have the compiler, but it is. That's not the one. Projects cast. It's like 10,000 lines of code, I think, right now. It's pretty small. 13,000 lines of code of a camel right now. VBS, Visual Basic Script, is the perfect language. Maybe. So yeah, thinking about everything is hard, but a lot of the new languages that appear and like are gaining traction, they purposefully don't think about a lot of things because that makes the language simpler, which is, in my opinion, I mean, it makes it easier to develop the language and stuff, but it also makes me not want to use those languages, right? Like Go, for example, Zig, and like all of these things, you know. They are nice languages, but they are not having enough features. But what they have is, I guess, okay. If what they have is enough for you, then good for you, I guess. Jai is probably like a good one, but I think one of the things that Jai is not going for example, is the memory safety, right? Like Rust is going for. So like at least that is not included in Jai, right? But Jai has a lot of good things. From what I've seen. You don't understand how Zig is safer than C? Well, it makes it a little bit more difficult to make a bug. It's not like safe, but it's safer, I guess. Yeah. It's like I don't know. How good do you think C is? C?
Hello, Pgorly.
Hello, Pgorly. I don't like C myself. No.
Hello, Natsu.
I think C is pretty bad as a language to develop software. It's a good language to learn so that you understand how computers work, but like using it, I don't think that's a good idea. All right, we just go over all of the IDs here and we see if there is a range that contains it, right? So we say found is false because I don't think we have a list like find methods, so we need to do it manually here. Found is false, iterate ranges. Switching to Java and C++ next year. Not that those languages are much better, but yeah. So we have start and end, and we say that if start is less than or equal than ID, and ID is less than or equal than end, then found is true. If found, then answer plus equal 1. We can also like break here, I guess. Something, and then we can do something like this. Winding block. Pulls. Unwind block true. We can do that. And that's going to be found. Unwinding. Wait, is that not what I called it? I forgot. I forgot my own language already. Oh, it's called unwindable. Yeah, that makes sense. Unwindable. Why unwinding? Unwindable must be expression. Okay, so this over here is something that I need to fix right now in the language, because I introduced yesterday the place expressions and references, as you can see over here. I need to fix that. That should be compiling. Unwindable. Unwindable must be expression. If it is a place expression, then and say compiler temporary expression like so. So yeah, we'll say let x be unwindable block unwind block 1 2. There we go. That makes sense. Unwindable as place expression. I feel like I want to change this keyword something else. Like in Rust, you would say something like block, you know, and then over here you say break block with true, you know. And this is like a long word. Maybe I want to change that. We'll do dbg print answer. Zik has block, break block. Yeah. Something like that, right? I just don't like like I cannot do the Zig syntax directly, I think. Well, I mean, technically, I guess I could, but it's a little bit weird. Russ has this, which you dislike in lifetimes too. Yeah, I guess. Yeah, but I don't like the Ziggs one too. I think because like the reason is that like, well, I mean, you dislike my rounding brackets too, unbalanced. What exactly do you not like? What is unbalanced? Because I'm using the round brackets instead of curly brackets. Is that what you don't like? But why? Quote starting? What do you mean quote starting? The only, like, you mean like the quote, when I quote the ASTs? Like when I do this, quote, hello? Because that creates the AST, you know, quote 2 plus 2. That's just the AST as a value. But like, why do you not like this? So what would you want instead? There are not a lot of languages that allow you to have ASTs as values, right? This is like there on both sides. Why would it be on both sides though? It's not a string. It's more like in Rust, you write quote macro. It's basically the alternative to the quote macro from the quote crate. So they're like quote 2 plus 2. That's how it looks like in Rust. You open a quote and you don't end it. Does it need to be ended? I don't know. I mean, that's I guess that's how you can do it. Yeah. But I mean, okay. I mean, yeah, actually, maybe you're right. It's just like a little weird. You know why? Because like then we need to not have parentheses, right? So then like so you're saying that 2 plus 2 like this should be the AST, right? I feel like in this case it's very easy to think that you're writing a string, because like what's the difference between string and the quote, you know? It's like this is very similar visually, I think. Red Corp, hello, did you win yet? You mean like on the Advent of Code? I think I cannot win. Because like I'm in a different time zone than you are. Right? So like how can I even win here? If Meep... I thought, yeah, Meep was the first one yesterday. Like these people are awake when it starts, right? And I'm not. So like how can I win? I'm literally sleeping. Yeah. But yeah, Betsag, what I'm saying is that like you want this to be the quoting of the AST? This syntax? So my problem is that, like, again, it's too easy to think that it's like a string, I guess. Although at the same time, there's going to be like syntax highlighting in the editor, I guess, for that. Is going to be different. And also, how do you include quoting an AST inside quoting an AST? Because now we need to have a, like, similarly to strings, right? Inside strings, you need to, like, escape quotes, right? So how would you escape quoting an AST? Because for me, it's really easy right now. If I say quote 2 plus quote 3, for example, right? Then this is my AST, right? How do I do this if I only use quotes instead of parentheses here? You know, then we need to be able to escape the quote then. You know, like yeah. I'm open to like suggestions of different syntaxes, but I don't think it works if we just like take the if we just do that, because we need parentheses. We have an opening and a closing, so like an opening and a closing ones should be different unless we do the syntax like this, right? So we require parentheses in between the quotes too. Then it would make sense, I guess. But but this one, there's no reason for this one to exist, I feel like. But you don't like Rust lifetime syntax for that reason too? But why? What's the problem, actually? The only problem is that you are used to quotes closing, right? But why are you used to? Like, I mean, sure. I don't know. I don't see a problem with that, honestly. The only problem with Rust lifetime syntax is that they are different syntax from normal variables. Like, why are they just normal variables? JavaScript and Bash both use this and that. No, JavaScript and Bash don't allow you to escape the ASTs. There is no alternative in JavaScript and Bash. That's different. In JavaScript and Bash, those things are strings. And this is not a string. That's the difference. This is AST. AST and a string is different things. This feature exists like in Rust in form of a quote crate. In Lisp, let's see, Lisp quote. Like in Lisp, it's also not closed, right? Lisp quote. Let's see. Like in Lisp, it's literally also the unquoted thing. That's where the name is like originally was originally is coming from, I guess, right? Yeah, they do it like this. They quote addition to A to B, and this is giving you like this thing. So this one evaluates, and this one returns you the thing itself. Bash does not do back quote. That is a legacy feature we don't talk about. All right, let's see if my solution works though. 3 input txt 664. Advent of code. Submit. That's the right answer. Let's go to part 2. Day 5, part 1. Are they, wait, are they doing like the advent of code? They're making it like easier every day, is what it feels like. I feel like day 1 was the hardest one of the ones, and so far, at least part 1 of this day 5 is the easiest. It's supposed to be the other way, right? All right, what do we do now? The elves are bringing this, that, so that they stop bugging you when they get new inventory. Would like to know all of the IDs that the fresh ingredient ID ranges consider to be fresh. Now the second section of the database is irrelevant. Okay, so we just read the first part of the input, and we give it all of the ranges that are fresh. Okay, how many? That's, I understand that. Check it in your notes. What? Check what? Oh, you mean like part 1 is solved? Yeah. Sure. Okay, the way I want to solve this, there's like a lot of different ways. I want to improve my trip anyway, because I use that as my collection for everything. So I'm going to use the trip to solve this. Basically, we are going to do something like this. I'm going to store the ranges that are fresh in a data structure, I guess, right? So every node in our trip is going to correspond to a range, and if it's in the trip, then it's fresh, something like that, if that makes sense. But in order to do that, I need to improve the thing a little bit. Let's open trip. Let me do directly in this repository first, though. I'm just going to say that trip is import trip. Like this. I'm going to use std prelude here. This doesn't work. I cannot import yet. I need to fix that. We can only include for now. This also should be import in the future. Okay, let's see, what do I want here? So I want to have a more what's a trip? It's like a binary search tree and a heap at the same time, which is why it's a trip. It's a tree and a heap combined. But for the heap part, we are using the random numbers, which is allowing you to, because of the RNG, it's probabilistic thing, to keep the depth of the binary tree logarithmic, which makes it like an efficient, relatively efficient data structure, right? Like normally for your sets, you use something like a red-black tree, I guess, right? But I don't know, I just like the trip. Why is there a binary tree? Here? Because because it's a trip. It's a binary search tree and a heap, you know? What do you mean, why? What do you need for this problem? It's not because I need it, it's because I want it, alright? Like I basically use trips to implement like sets, right? So we are going to have a set of fresh intervals, right? Yeah. Why do you want a set? Because we want to merge. So like we are given in this problem the intervals that are intersecting, right? What we can do is we can like sort them and like do like like do it like the other way, of course, right? But we instead want to like maintain the way I want to basically write my solution is that I want to maintain the set of non-intersecting intervals, right? So when I insert a new interval into the data structure, I'm going to remove every interval that is intersecting with me, right? And then insert the new one, right? And then if the ones are intersecting like on the edges, right, then we will like shorten them basically. You did it the pro gamer way. Compare every range to every other range. Yeah, I guess, I mean, technically the input that they give you is like really small, right? How many intervals are here? Just like 200, right? Less than 200. Yeah, this is like, yeah, they don't, you don't need like an efficient solution here for sure. Why is it 40,000? It's not yeah, it's 40,000. Yeah, my math is bad. Yeah, just 40,000. Easy. Yeah, I just want to do it a little differently. If you have seen my solution for day 3, it's also like it's also something that is completely unneeded. So for day 3, I did it in O(n) times 10. Although I think I can do it even more efficiently, like O(n), and like, you know, well, I mean, technically the original solution is like n times 12, which is same as n times, yeah, but like if they told you that you can select more than 12 characters, right? Like any character, any like, any amount here, then like, you know, yeah. It's just so that we now, you know, like we don't end the stream in the first 5 minutes. That's why. That's why we do it this way, okay? We did the sort for this one though. That one is short. Nice. Very nice, clean, readable, and easily maintainable code. You're just missing comments. Like you should add comments to your code to make it like just a little better, you know? But yeah. Can you do comments in Bash? Yeah, you can, right? Wait, can you do like comments in the like not line comments, but like, you know, so that you don't end the line? Can you do that in Bash? Not, you cannot, right? Yeah. All right. So
Hello, Nerdsel.
the Nerdsel. You just have a string literal hanging out though. Oh yeah, that's right. That's what they do in Python. Do a string instead of a comment. Wait, is there no like cast cannot either? What do you mean cast cannot either? Look at this. You want me to show it to you? Look at this over here. I just select this. Wait, what's the command? It's Control-Shift-A. There we go. We have block comments. It looks like this. What do you mean cast cannot? Cast can. Yeah, you can like select something like this and comment it out. I think they can also be nested. I'm not sure if I have nested comments though. Like if I have the comment like this. Yeah, I think, yeah, see? It's nesting it. It thinks that this is all a comment now. But if I close this now, it's going to work, yeah. OCaml style. Well, it's not only OCaml, I guess, right? I mean, it's OCaml style because of parentheses instead of like slashes, I can see. Yeah. But there are other languages that do that. I don't know, it just makes sense. Yeah. I think I would have done this even if I have not seen OCaml. Alright, so we have a trip. Trip. What I want is to... So right now I can split at a given index. But what I want... What I want... Like, how generic do I want this to be, though? Like, I want to split using the value, basically, because it's a binary search tree, but I have not used... Well, I mean, right now, the way I'm doing this is not even a binary search tree. I'm not guaranteeing that, right? But if we construct it in a certain way, then yeah. Like, I think I want... the split function to allow me to select... Like this should have the function as an argument. Which tells me if I should split the left part. Like I mean I can do easily the solution for this problem specifically, but I wonder how the data structure should look like if it's like generic over what it can do. Let's do the solution for specifically for this problem though first, I guess, right? There's going to be a trip which holds segments then, right? So values for me let's do this segment set, right? So segment set is what I'm going to do. I'm going to say that type T is trip of not type, const T is trip. So we have a segment in every node, right? Yeah, segment where segment is type. We just say that it's 2 in 64s, right? 2 in 64s, sure. That's the segment. So the trip of segments. Then we want to be able to say add a segment C program lover. Hello. How rude. I didn't know where to post it. You mean your pixel art? Well, I mean, why did you post it in Cast? Cast is a channel about Cast programming language, not about pixel art, right? But yeah. So add is a function that takes the current set, right, and gets another segment, which is segment, right, and we give back the new set. It's immutable data structure. Could not find segment in scope. No, it's just the language server. It's not updated yet. Makes sense. The invent of code, I spent more than an hour to turn a less into a less than or equal. What do you mean? Oh, like that was your bug? You had a less, but you needed to fix it by adding an equal? I see. Yeah, so what do we want? Like, we want to be able to like create a new one, which is just going to say trip create here, right? This is a function returning that. And then we want to add, right? And then we will want to find the total length, right? That's like literally the answer that they want to us. Total length. Total length is we have set of segments, and this gives us the total length. Yeah, like so. In 64. Okay, so now we need to like do these things. Let's see. Panic to do. This way you are not going to complain, right? Let's just pretend that this is the API that we're going to implement, right? So the solution is going to be that ranges is not a list anymore, right? We can do the part 1 using that stuff too, which means I will want another one, right? I will want a function contains. Contains is we have set and contains the point, I guess. You know, which is in 64, and it just returns boolean. Yeah, let's do that. So ranges is segment set create, and then over here we have start and we have end. So we don't do list pushback. We instead say that ranges is segment set add ranges start end, right? And then over here we say we don't go over. We just say that if segment set contains ranges ID. That's all. That's like the part 1. Right? So yeah, we say that yeah. Let's answer be if part 1, then we do that. Otherwise we just say that answer is segment set total length. That's all that's needed. Contains will take this by reference, I suppose, and total length of also only need there's the reference. This needs narrow. All right, so and now we only need to like implement this, right? So once again, this is going to be a data structure which contains the non-intersecting segments only, right? And we can edit the sets in the segments in any order. Yeah. So maybe I should write the contains first. It's going to be something like this. I'm going to match t with match t like this. So if the set itself is empty, then we just return false, right? Otherwise, if it's a node, then and figure out. It's not t, I need sets, right? So if it's a node, then in the node we are going to store the segment as its value, right? So I need to say that if node, so if node value, so start and end is node value, right? That's what we store here, right? If point is less than start, then we basically need to find in the left subtree. So I need then to return contains node left point. If point is greater than end, then we need to look in the right subtree. Otherwise, we just return true, because our current node is the segment that contains the point. That is if I have the segments including. I don't really like the segments that are including, so let's instead do more than or equal, because I want the right end to be exclusive. That's how you normally do stuff in programming, right? So I will stay over here, end plus 1. And by the way, I cannot do plus 1 because 1 is not an int64. I need to do 1 as int64. Which is similarly to day 4. I need to like, no, similar to day 3. I need to actually implement it in the language, but for now we do this. We say that in order to convert in 32 to int64, we convert to string and then back. All right. For now. So currently Chaos does it a bit like how Bash does it. Yeah, I guess. So that's the contains. The total length is also should be easy. So this should be match set with if it's empty, then we just return 0, right? And if it's a node, then we return let start and end is node value. We return end minus start, which is the length of the current node, plus we return total length of node left, plus total length of node right. Let's do this. No? Wait, did I not do the formatting for the pluses? There we go. Yeah, I did do. Yeah. Something like that. Wait, didn't I try to move this to the beginning? Okay, so now the only question is how to perform the add. So to perform the add, I need to split the trip so that it into like I need to get the part that is strictly to the left of the segment that I'm adding and strictly to the right of the segment that I'm adding. Then in the middle there will be like potentially some more segments which I will need to cut. But also I don't really need to cut them because I can just extend the segment and like merge them. That could be another thing. Yeah, I can like say like if I have another two things, which is the minimum, you know, the minimum in the set. And the maximum. Like not the maximum, but I want like united end, you know, like if we like I don't know, like the entire range of IDs that is covered, so covered end and covered start maybe is what I would call it, right? So this only makes sense if it's not empty. So if it's empty, would panic. If it's not, then so for the start here, I will say that and to match node left with empty, then node value start. And if it's a node, then we return covered start node left. I guess. Field start is not there. Field start is yeah, wait. Yeah, because it's not. Yeah, in this case we return let start and is node value and return start. This must be a fetch arrow. Semicolon. Something like this. And then the covered end is similar, but it goes to the right and it returns the end. Okay. So now I want to split the thing here. Yeah, I'm going to split so that this thing does not contain. Let's see, let left and right be split, set, split at the start. Yeah, that's what I need to do. So like the segment is, you know, start and end, right? So we split at the start here. So yeah, we split that. Then we say that let middle and right to be split right at the end. Then we forget about the middle, but we'll return merge left, right with the new one, Trip, singleton, start, end. I guess I'm not actually going to use the minimum and maximum if I do that. So then splitting will split the node in half then, if needed. This would be trip merge. I already have this written. But the splitting needs to be like re-implemented. Let's see, split. We split the set at a certain point into two separate sets of non-intersecting segments, right? At position X in 64. This will give me two sets, TT. That means that I need to match set, right? If it is empty, then we just return the set itself, I suppose. If it is the not empty one, so if it is a node, then we say that if point we do this, let start and end be node value, if x is less, so if the split point is in the left subtree, which means that it's less, strictly less, or equal, I guess it's the same one, right? To start, then we need to split the left node. We do split node left at x, and this is going to be left left and left right, and then we going to change my current node, right? So I say node is node priority is node priority. Left is left right. Right is node right. Value is node value. Was there anything else? There's also count. Count. I don't need count in this case. Like in this case, I don't need, right? So like in order to make this a generic data structure, the zero count is 0 here. So in this case, let's just do panic to do here. Oh, this should return set and set, I suppose. Yeah, there you go. Do I need parentheses here? I do. So I return a left and node. And like this new node. I guess I just do that here directly. No. I like that more. So that's in if the split point is in the left subtree. If the split point is in the right subtree, so if x is more than or equal to end, then we split the right subtree, which means that right left and right right is split node right at x, and then we create the node left is node left, right is right left, value is node value, priority is node priority, count is 0, and we return node and right right. Why LSP is so slow? Because it's crashing, it's leaking memory. As one thing, and another thing is that it's parsing the standard library from scratch every time. I need to fix it, but I just didn't get to it yet. It was faster before, but it was show me the fake errors from, because I was like changing the types in the standard library while running code. But I guess like there is another thing where like the formatter and the syntax highlighting can work before I have compiled this stuff to show the errors, I guess. So that part could also be faster, right? I should not wait for the compilation errors to format my code. Should just wait for parsing. Okay, and then otherwise we otherwise I need to split my actual node in half, because my X is literally in the middle. It's strictly more than start, and it's strictly less than end. So I need to split my current segment into two segments here. So yeah, I don't need covered start and covered end. Let's remove this. Beepend compiler make, my bad. Can it be because I'm touching the microphone? Can it be because I'm touching the microphone cable right now? I'm touching it. Is it beeping? I'm touching it right now, like yeah, I'm like moving it. No? So it's not about the cable then. All right. Yeah, I'm pretty sure it's a software issue. So yeah, over here we say that we have two separate segments, right? And we split at X literally, right? So we say that we return it is bad ground in your wire, probably. I'm pretty sure it's a software issue because, like I said, this was never an issue on Windows. It's only an issue on Linux. I don't know what else. I mean, the one thing that we still did not try is another microphone. But I need to make sure that the other microphone is actually working to test it. It's always happened when you get into your thoughts and start rapping. Yeah. Let's see. So we have two segments now instead of one segment, which is start end. So we have the left segment, which is going to be segment, right? It's start and X, and right segment is X end, basically, right? And then we return two separate things. One of them is merge. So this is going to be trip merge node left with left, and merge right with node right. I think that's what I need. Trip merge. Could also be the microphone is most definitely ground related. Okay. Yeah, maybe I just need to get a new microphone. Maybe it just happened. So maybe it's just an accident. Then when I switched to Linux from Windows, my microphone also started to have grounding issues, because it actually, yeah, there was something happening. It was falling down. So maybe I actually broke it somehow. I don't know. But left is going to be not that. It's going to be a trip singleton. So it's not a segment. It's a single new node instead of the current node. Yeah. There you go. This should work, right? It says type check failed, unit is not equal to something. Let's restart. No, type check failed, unit is not value. Singleton merge. Node right. That's two trip nodes, right? What's the problem? Left is node, yes. And right is also the same thing. I don't actually see the type issues here. Type check failed. Unit is not. So this entire thing. Someone thinks that it's a unit. What if I just return here, left and right? Which is not correct. But can this work? This also does not work. Why not? What's the problem? This is my note. This is my stuff that... Is there a bug right now? Can I just say over here, panic, and then it's going to work? Nope. Nope, it's not working then. I have type check failure. Okay, what if I say over here, panic? And over here also panic. So this works, right? So what's the type of this thing? It's 2 nodes, yes, just like it needs to be. So you are saying that maybe the bug is over here somewhere. Left, left, and left, right are 2 nodes, yes. Which means that if I return those... So this still type checks. If I do that... Now this doesn't type check. So I have a problem here, actually. I do the semicolon. Look, this is... Okay. This should be different. I understand, though. It's my error messages are really bad. I did a semicolon here instead of a comma. Which resulted in this thing to be treated as a unit. So it just ignores this part. It's almost like this should not even parse. Okay, so this should work, right? It type checks. Let's just run it now. 3 input txt 664. That was the correct answer, right? And then we do part 2. 14. Is 14 correct? 14 is correct for the example. And part 2 on the actual input is going to be this number. Let's submit it. Okay. And it is the right answer. So I did solve the advent of code, right? With a trip. But obviously the trip is not needed here to solve this, right? But like, it's because it's my favorite data structure, I had to. But I want this to be moved into the actual trip. I want this to be moved into the actual trip, the standard library, and somehow make this more generic, right? So because trips, they have like values stored in their nodes, right? And then the way I'm splitting here is I'm doing it based on the node. And in this case, like, I have, like, yeah. How do I make this generic? I don't know. How do I make this generic? So splitting should basically tell me. Like the generic one, which should say, should I split the left? Should I split the right subtree? Or should I split the node itself? Because only 3 things should be happening, right? So here's my generic tree. I will have the split as, right? But I guess it should be a generic split function, which takes as the argument, like, the way we do the splitting, right? So like it should be like a splitter T. So, and what is splitter T? I mean, not the splitter. Let's just say type you know, like yeah, I guess I need something like this. I want something like this, you know, split split I don't know what to call this, but basically I want to know for every split for every node, I will want to know, should I split the left subtree, or should I split the right subtree, or should I split the node itself? And in case I'm splitting the node itself, I need to give it the double value here, right? Yeah. So this should be basically a function from t into this split t, right? So this is the function which we use to split, right? So what could this be called? It's like a comparison function for the sorting algorithm, but in this case it's not like a comparator. So like when you have the comparison operator, you say that it's either less, greater, or equal, right? That are the three things that you get from a comparator. But in this case, if it's equal, it could be also inside, right? Because we are potentially because like so in the case of this solution, we are comparing the ranges against a point, right? So when you compare a range against a point, the point can be on the left of the range, it can be on the right of the range, or it can be inside of the range. In which case we like split it into two ranges. I don't know what to call this. It should be type. Maybe I should call it, you know, split node. I don't know. Let's call it node split behavior. Maybe. So we either split the left subtree, or we split the right subtree, or we split the node itself. Right? That's how we do it generically, I guess. And so we just match. Now we just match the node. I guess like it actually is easier to do. Take this from here then. I'm going to match the current. If it's empty, then we just return two empty ones. Maybe like there should be new empty ones instead of the original one, actually. This should be in parentheses. So if this is a node, so we don't know that the node value is start and end because this is just a t, right? So this is a generic one. So instead we are going to match applying function f with node value, right? And this is where we match the behavior, right? So what's our behavior? If I want to split the left subtree, then we need to do this, right? We split the left subtree using the same function. Priority node value. So node value remains untouched. I guess count in this case is something that should not even be, because like that's, and length also. Should length even be like a thing? I don't know. I mean, let's keep count, whatever. More generic trip implementation is what I'm doing right now. So I just say in this case that count is length left right plus 1 plus length node right. Which honestly it should be update this with these. Yeah. Update this with that. I think this one should be put in the top level. Yeah, maybe I just do over here. That node is update node with left right node right. These are my new subtrees. And this is already recalculating my counts then properly. Okay, so we do this, and then if we do the right subtree, then we do this. Node is update node with node left and right left. Okay, and this over here, the last one is split the node left and right. This is two values, so now we have left is singleton left and right is singleton right. Like that's all. Can I have a match over here without this being the thing? Type check failed. What we're making? What is this? This is cast. Playboy. Orphan Hunter. Welcome. I'm making a programming language. I was solving the advent of code with my language. Today's advent of code is really easy. So I'm now improving the language, making a more general trip implementation. Trip is a data structure, which is my main data structure, which is how I use this data structure to do the lists right now, and sets and queues and whatever. This is the data structure that can do everything, kind of. Is this for fun? Mainly for fun, yeah. Technically, this is going pretty well, so maybe at some point it actually will be like a usable thing, a usable programming language. But that's a maybe. Did I just break all my code here? How did I break this? I check fail. Like, because this... oh, it's because this must be T. That makes sense now. That makes sense. Because I moved it out. This takes data T. It does... Yeah. This takes data T. And this returns the new... yeah, the node. No, I don't need this for work, no. I don't need this for work, but yeah. I don't think I've written anything manually. What do you mean manually? In like 6 months? Are you saying that you are the vibe coder who is doing AI to code for them? What are you coding then? Yes, sir. What are you coding then? And what have you achieved with AI coding? Because I feel like AI can do like some really simple tasks, sure, but complex ones, I don't know. I don't think it can write my programming language for me. Is this part 1 or part 2? I already solved both parts. Hi. But I am now like the way I solved it is like using the data structure, which I want to like make more generalized and move it into the standard library of my language. You got employed and trained neural networks with 80% Claude help. All right. But have you done anything useful? Yeah, so like in case you are wondering, yeah, I'm making the generic trip implementation. Trip. I use the trip to implement the set of non-intersecting segments in the in this advent of code, right? So yeah, we basically made a data structure which can hold the set of non-intersecting segments, because in the original input that they give you, the segments are intersecting, right? And if we have them non-intersecting, then like it's nice and useful. All right, what's wrong here? Can I remove the split? Oh, I think it's because no, I just don't have the split add anymore. Never mind. Wait, what's the problem? If I comment this out, I still have this. Update left data. Left data. Type check failed. Left data is this thing. Makes sense. This is the data of the node. This is the node data. I should, yeah. Maybe I should work on the named types today or something, so that this is more readable. Subject failed. So we expected reference to some type into some type. Why? Oh, because updated is this update. I see. I see with the problem. Because I had two functions that are called update. And now, because, yeah, there should be like a different error though. But I have two functions named update. This should be like update at, I suppose. Because that's at a given index. Yeah. Okay, nice. So that works. Let's bring back the split. I think this should type check. It looks like it's not type checking because update. Maybe I should call this like update data or something. So we have the data and then left and right. Oh, because these are... I see. Why don't you just... Why are these even in parentheses? I should just do this. Left and right. Yeah? Yeah. Update data. Like, with the left being this. Because we can have the mixed things. Some can be named and some can be unnamed fields. That's a lot cleaner, I think. Right? So I update this data with left being this and right being that. Yeah, yeah. We do left is this and right is that. And then I update here. Left is this and right is that. You can format this thing. I believe in you. Yes, there we go. Do some trailing commas here. The X though is F. Now. And this is not trip merge, this is just merge. And this is two singletons. And node is not... No, this is correct. I just forgot the this thing. Some syntax issues. Back, Mr. Penguin. Welcome back. So now I can implement split add. So split add is the thing that's supposed to split my trip at a given index. But we can implement this using the generic split now. So we have a split add. Split add it's a function which takes the trip and gives the index, right? And this should give me two trips back. Right? And this can be implemented using just split. So I'm just splitting the v using the function, right? And this function is t. Wait, this is not t. Yeah, this is not just t then, because this should be... Because that's not part of the value, right? That's like another thing here. So do I give it as an extra argument here? I can. I guess I can. I don't know. We have value and count in 32. I can do that. Node value and count is node count. We can call it like, I mean, yeah, this is the count in the subtree, and this is the value in the root of the tree, right? So we split v using a function that ignores the value, but we want the count. And then we say that if index. Wait, but then I need to like, yeah, how do I know? Because I need to like, okay, I need more data here, right? So my splitter node split behavior. Node split behavior. Let's call this node splitter, which is a separate type. Node splitter is like a function, right? Like this. But I need to give it more information. Kind of. I mean, I guess I just give it the node in general. Maybe that's all. I just give it the node itself. I mean, node data. By reference, maybe. That would make sense. So now we say that if index is less, so yeah, we just have the node here, right? Kind of, which is the node data. So if index is left, then length less than or equal, then length of node left, then we return split the left subtree. Otherwise, we return the fact that we need to split the right subtree. What are you saying? Underscore does not have fields. But this should be inferred. This should be inferred. Why is it not inferred here? This should be inferable. Type check failed. Oh, yeah. Because I guess over here, this should be just node then now. Does not have field. Node. No, this should be like reference to node, right? Okay. What else? Could not find node data. I just called it data. That makes sense. And then this, so now this is a reference. So I kind of like need to dereference that before taking the dot, because we don't have the auto derefing right now. Or I could have like similar to C, the like the arrow keyword. But this should work now. Okay, and then let's implement this. So this is the segment set, the set of non-intersecting segments. C is kind of based. I don't think I should though. Like we should do it similar to Rust, because like it can be like a reference to a reference similar to Rust, right? But at the same time, I mean, auto dereferencing is kind of like implicit, right? How do you do it in Zig? I guess that's why in Zig it's like the postfix operator. I feel like it should have the same priority maybe as the dot. So the syntax should be like node like caret dot left, right? So I don't need parentheses here. And it's like two separate operators, right? You know what I mean? Because I guess in Zig it would be something like node dot... Is it dot star? I think it's dot star and then dot left. Is that how you do it? Zig dereference. Keyword reference. Pointers. Give me the documentations about the pointers. Hello? Zig has two types of pointers, this and many item pointer to unknown numbers. So how do you dereference them again? You use a reference to obtain a single reference. Pointer arithmetics. Where's the dereferencing? Pointer cast, volatile, alignment. Yeah, it's the dot star. Right? So if you have a pointer to data and you want to have a field when you want to access to the field in the data that's behind a pointer, then you do dot star explicitly and then dot field, right? So yeah, should I do just the same? I feel like I should like wait with automatic dereferencing. But I need this syntax to actually be parsable. So for now, we just do that. Anyway, so yeah, now I can implement the segment tree using the trip, right? And to do that, I can just so we have create. We split this. So I just over here, yeah. We just do a trip split set using the function. So we have node, and then we say that let start and end is node value, right? If x is less than or equal than start, then we say split the left subtree. If x is more than or equal than end, then we split the right subtree, and otherwise we split the thing itself, right? So we split the node into two segments, which is start x and x end, right? So instead of all of this, we just say this. You guys have a syntax problem here? Else if. I forgot the if here. Node. Yeah, and over here, node is a pointer. So we just need like node this. Node referenced dot value. And it's 3 part 2. I just check that my output is the same. 3507 80 32 43. Yeah, this is the correct answer. So I still like implement the total length manually here. I feel like, and like contains, I feel like this also could be generalized more. Yeah. Let's move the trip into the standard library. Here. I prefer to see switch case to Rust match. What is happening to me? What do you mean? What exactly do you prefer there? The syntax? Or the semantics? Because C doesn't have pattern matching? You prefer no pattern matching? Some weird masochism? Yeah, maybe. Okay, let's actually take a look at default syntax rules. Right. So we have the dereference operator over here. It right now has the priority of 61. So I think this is the correct priority for the references, but the references should be higher priority. And yeah, I think that making it the same as the priority for the dots left associative at priority 70, that makes sense. So basically what this means, let's go into the REPL here, right? So now I should be able to write code like this. Should be able to write code A dot B, right? Is this actually treated as a single thing right now? Yeah, it does. Did I do that on purpose? Like the lexer? I thought I would also need to change the lexer, but I guess I do not. Single, yeah, because it says single punctuation. Yeah, and we can do a double reference then too, right? Easily. So we can do like reference to A dot B dereferenced twice dot C. So this is a reference to a field C. So a field C of dereferenced twice field B of object A. I feel like this is properly parsed now. Yeah. Nice. So if I search for this, it's not there. Trip. Why could I not find this? I wanted to look for this, for the dereference and the closing bracket. Oh, because closing bracket also needs to be, yeah, it's literally only in this place. Because brackets also need to be escaped in regexes. So I can just do this now. And that also works. Cast examples lists. Seems like this still works. More generalized trip. So what should I do next then, if this works? So this trip can be removed, and I will say that I don't do this trip. I instead say that trip is like STD collections trip, right? And I will say I'll search for this. So this should be like just node dereference dot value. And that should work as soon as the language is updated. There we go. And we do day 5 part 2 input. Okay, seems like it's working. Part 2 day 5. Let's just commit that. So like, okay, sure, I see this, the syntax as, right? This is a little bit annoying when I need to like convert an integer to a string. Do I actually implement traits right now? It's probably not even like that difficult, but like, I mean the way I was doing it, it's not that difficult. But so there's one problem with traits in like Rust. I can like if I add the traits to the language, the problem is that I can no longer type erase the functions, right? And I will have to monomorphize them. The orphan rule is like a separate thing. The problem is compilation times, because one of the the biggest compilation time in Rust is monomorphization. At least like in my case, when I was working on this language before rewriting it back into OCaml, monomorphization was taking the most time. So I want to have a fast compiler of my language. So I want to be able to just type erase, and it should still be interpreted properly, right? And like when I'm compiling, I can compile putting things into the heap without monomorphization, compile quickly, and just be able to run it, you know? And the reason you cannot do that once you have traits is because let's say that you have code. Let's say that you have code function foo. Well, this is a generic one over t, right? And then I say that let x be I don't know 123 dot parse unwrap. This is of type t. T is like something that can be like from string, I guess, right? And then we I don't know, plus debug, and then we say dbgx, I don't know, something like this. Std stir, std fmt. Everything would be like didn't trait. Yeah. So okay, well this doesn't compile because t should be from string where error can be debugged. Std fmt debug. Sure. It's called error, right? Yeah, there we go. So like this compiles, right? But basically, this function doesn't actually have any arguments. It only has a generic argument, right? So if I remove this, then how do we know what function to call here, right? If I don't know what t is, then I don't know what function to call, basically. Which means that so the idea here is to have the trait implementations. Let's have something simpler. Let's have something simpler. Let's just have I don't know. Let's just have something really simpler, you know, like we have trait foo, and this has function foo, you know. How about this? Yeah, how about this? And then we have a function foo, which takes the argument, which is trait foo, right? And it's all it does is it just calls t foo. How about that? Simple as this, right? So so this function is the function that is implementation of the trait for type t. If I do type erasure here, right, then I don't know what function to call here. That's the problem. So the idea is to have the trait implementations as also first class things, as values. So instead of saying that this is a generic function taking t, type t, and this is foo, what we want is we want to have like a hidden argument. We want to have a hidden argument, you know, the t foo implementation, which has the type you know, t implemented as foo, like whatever, however you call it, right? So this is a hidden implicit argument is the idea here, because that's how you do it in the languages. Stealing from Nigel's language again, I see. No, this was the kind of the original. No, okay. Okay, sure, we both steal from like from Scala, for example, right? Because that's how Scala does it, as far as I understand it. I don't think you even need to hide the first argument. No, it needs to be hidden because I don't want to call this function like in code. I should still say foo t, right? I don't need to give it the argument explicitly, is the idea, right? The whole idea is to be not very verbose, because there could be like a bunch of these things. That's literally how Scala does it. It's called this Scala. They don't call it implicits anymore, right? They call it contextual parameters, like contexts, right? Literally the same thing. So we have the comparator, right? Let's say, so yeah, over here, we have a function maximum, which is a generic function for type A, right? So, but in order to get the maximum, we need to have the comparator. So this comparator is a hidden implicit argument. They call it contextual argument, whatever, right? But basically, you can have maximum 10 and 6, maximum hello and world, and it just works. You don't give it the comparator explicitly, you know? Which is very similar. You could carry the first argument. The first argument is a type which returns a function that applies the function to the type. Yes, but as you can see, this is how we are supposed to use it. We are not giving it the comparator explicitly. The whole idea is to be implicit here in code still. So yeah, I'm not like really inventing something new here. Scala already does that, and like some other languages. So basically, at type checking, at compilation stage, we figure out what is the hidden argument that we're giving it, right? And so, but then after I have after the compiler figured out the implicit argument, we can type erase after that, and that means that I will still be able to compile the function once instead of compiling it every time separately for every type parameter. That's against my vision, but a language that made it entirely explicit sounds very interesting. No, my idea was never to be very explicit. No, the idea is to be expressive, right? Which requires implicitness, right? My idea was never to be explicit. I don't think so. Misunderstood. The idea is against your vision. Oh, your idea is against my vision. But could be a separate thing. Yeah. So your idea is to have the first argument is a type which returns a function that applies the function on the type. Normally, how do you do this in OCaml, right? For example, in OCaml, it's a lot more explicit, right? So you have the function maximum, right? So in OCaml, you would write playground. You would just write something like this. You would say that a maximum is a function that takes a comparator, right? Which so it's a generic function, but it takes a comparator, which is a function taking two arguments and returning like the ordering, right? And then you give it the two arguments, and it determines the maximum, right? Something like this, and then this is going to be like a function comparator AB into if comparator AB is less than 0, then A else B. Something like this is the implementation, right? So then you say that like the maximum integer is maximum with like A minus B, right? Because this is like the comparator which is comparing the integers, right? That's what you're saying? That's already how you do it in languages like OCaml. I guess in Zig you also only do code like that, I'm supposing. I suppose, right? So like to this sorting algorithm, you always give the comparator because you have no idea what's the default comparator. So it's always explicit. There's just a single function, but could be a full vtable. Yeah, I guess, sure. So we can have a module, right? It's okay. So we can have a module type, like, you know, like ordered type, right? Which defines the type, which defines the compare function, which defines the equality function, and then we take the entire thing as the argument, not every function separately, but the entire thing, which is the vtable basically, because now we have two methods basically instead of one, right? So but I think OCaml cannot like, I think OCaml cannot say that if this over here is not the function, but this is the module, you know, module C ord. Do I do module ord here? Yeah, I guess. So I think I cannot say over here this is ord.t, right? Because it's unbound, yeah. So like you need to be like generic over type A, and then you need to say that this is like matching where type T is A, and then will you like match it this way, you know? And then so this now is the vtable, you know? I guess we can call this literally the vtable, right? So we have module vtable, and then we say over here vtable.cmp, right? So something like that is how you do it in OCaml already. But I don't like this. This is very explicit. This is very explicit. This is why, one of the reasons why I don't like OCaml and Zig and stuff. I like my traits. It does have the advantage that like you always know what it is. Kind of, right? I don't know. Could we extend it more to have compile time versus runtime vtables and functions which can be returned and mutate vtables? Yes. But basically the idea is the same. I literally have this idea explicit. Yeah. Like, so we have a hidden argument. The hidden argument, I think that's the next step. I should be able to move the things from being a runtime argument to being a compile time argument easily, and that is the process that we will call monomorphization, right? Where we basically fix a specific argument to a concrete value at compile time, and we create a dedicated monomorphized function or something like that, right? I think. But first, I want to focus on the speed of compilation, not on the speed of the runtime. So I will just start with passing these like vtables or whatever hidden arguments always at runtime, I guess. So I kind of already have that. That's just called the context system. It's just not being inferred right now. I already have it though. We can have something like this. So here's my REPL, right? We can have function. What's the current syntax? Let me see. Current context. Current scope. And to look at the standard library, and we have the loop body, right? So we have a context, right? So I think we do this const like, I don't know. So I want to have the comparator, right? Comparator. It's a context of a type, which is a function. So let's say that I don't think I can do it generically right now. So this is a function that takes integers. Use std prelude star. Maybe I should just do it not in a REPL. So we have a comparator. Is context, which is a function in 32, in 32. Maybe like this instead, because I don't like carrying too much. Function type cannot be expression. Wait, is this expression? I feel like this should be a type expression here. Can I just do type? There we go. So then we have the mechanism to retrieve the current comparator, right? So right now I don't have it. So let's say that we have a function f, which, so the function maximum, right? The function maximum as a function which takes two integers, a and b. In language like Rust and Haskell and Rust, you have the advanced type systems. You run into the limit. You have types. Then above that, traits. Sometimes you want to reason at a higher level of a group of traits. Rust could add that, but then there would be just the next level. Well, I mean, I think that for me, it's like already solved. Because I have types as values, so types, they are already on the same level as the values. They are not really much different. So for me, and traits for me are also just going to be basically the types, kind of, right? And then I just specify what's the type, like, and yeah, I guess like trait implementation is just the vtable basically, right? Kind of. So yeah, we have a b. Having types as first class values and generics are just functions that return types and which can be freely manipulated would break the ceiling on this. That's literally what I'm doing, yes. Yes. That's literally what I'm doing. So we have AB, and then we say basically trying to get current comparator, and then we call that function using A and B. And if this is less than 0, then we return A, otherwise we return B, right? That's the function. So let's say maximum of 1 and 2 is context unavailable, right? So right now, this should, this is failing, right? Technically, this should not even compile, but I don't have the compile time checks for this yet. But if we say this, if we say with comparator being equal to AB into A minus B, with this comparator, calculate the maximum of 1 and 2. Inject context must be expression. Inject context must be expression. What's my syntax? Did I forget the syntax? With context type is equal to value. Yeah, I think that's the syntax. Maybe the priorities are different. Like I need to do that. Probably. Yeah, there we go. So the maximum of 1 and 2 is 1, but why is that? It's because this returns... well, I mean, it's actually because the implementation is incorrect. Less than 0 than 8. This is actually the minimum. Yeah, let's say that minimum is maximum or something. So the minimum of 1 and 2 with this comparator is 1. And then the minimum with this comparator, where we return B minus A instead, is going to be 2. There we go. So like, basically, I can supply the function here. I can supply the comparator implicitly into this thing. And this is local to the current scope, right? So we have trait implementations that are scope local too, which also is how you fix the orphan rules, because there is no global trait implementations, there's only local trait implementations now. So like the complete type of the function minimum here, it's not just an integer, it's not just 2 integers that return an integer, but it's 2 integers that also require to be to have the comparator in current scope, basically. That's the idea for the language, right? We have that's why it's called contexts, because this function will need to be called in a context which knows how to compare, right? In a context with the comparator. All right. So I already have this. What I don't have is what? What I don't have is just the operator that is implemented inside of the language, right? So I want to move this into the language. Also, I don't want to work in Vim. Let's open VS Code. So I want the rules to not these rules. These rules. I want these rules to include the as operator. Value as type. What should be the priority of this? The priority should be 62. Should it be like higher? It should be higher than return. Maybe it should be 61. So it's lower than the variance. And it should be lower than the reference 2, I think. It should be like 65, 60.5 then. So you can do, you know, like none as integer. And this should be parsed properly, right? I don't call this type though. We cast the value into the target, and target is not necessarily a type. Target can be like a thing. Every time you open this file, a bunch of brackets angrily look at you from the distance. So target is integer. Yeah. So how do I like combine this though? Like what should this be desugaring into? This is just syntax sugar then, right? So like 1 to 3 as in 64 is just syntax sugar for what?
I wanted to do this as a comment, but that redeem is no longer there. Every time you open this file, a bunch of s angrily look at you from the distance.
Oh, you want to do a comment? You want to pollute my code base again? But my code base is so clean and nice, right? I have perfect code, no spaghetti or whatever. And you want to litter it with comments? So I think this should be syntax sugar, like to basically 1, 2, 3. It should be syntax sugar for basically this type of 1 to 3, type of 1 to 3 as into int 64, you know, dot into 1 to 3, right? Type of 1 to 3 is like is just like the type of this thing, right? So that's what actually like x, I guess, as in 64 means. So we have a trait into, and I use square brackets here. So we do that. So into in 64. Wait, but if I use the same operator, then it's like a little bit different, right? I can not use the same operator then. And like, yeah, I guess like let's do the more generic one first. What is it? What does it mean if I want to say foo s trait, right? In general, what does this mean? What does this mean? So in my previous implementation, this was like a built-in thing, but yeah. The previous implementation would need more morphization, like I said, so I don't want to do it exactly like before. So I want to use the context system instead, which would be just so foo s trait foo as trait. Foo in this case is type, right? So we have some type T as trait, basically, right? And this should basically be current trait implementation of trait T, because I think trait is just going to be like a generic thing. Current trait T, but this is not named, so I will, I guess, name it trait implementation. Still, trait implementation trait T. But this is but this means that current trait implementation. So this over here is a type. So right now I have the concept which is called context type. Context type just contains the type inside, but it also has the ID. Why do I have the ID here? Like in the previous implementation, I could just have any type as context. But in this implementation, I wanted them to be named. So I have IDs. Where am I using this? That's not correct. Like, hello, OCaml, can you like go look for references? Like, this is not the reference of, like, this over here is not a type, it's a field. Hello? Find all references. This is not the references to this ID. This reference to this ID, which is the type. Find all references to this. And this doesn't have any references, which is false. I guess I need to like see what. I guess I need to look at the interpreter. Interpreter common. When I have expression current context, that's what I need. So I have current context, context type. So I'm just finding it by ID. Yeah. Just finding it by ID. But if I don't know the type, this allows me to not know the type. This is what allows me to not know the type. But in case of generic context types, like trait implementation, wait, I mean, actually, yeah, no, it's generic because this contains T. So I cannot know its ID at compile time because of that. Well, but it's a hidden argument to the function. So just the implementation here is going to be different, right? This is going to be the hidden argument. The contexts, right? Which means that I can find this ID. It's just in the current, yeah, we have state contexts, and context type ID. Yeah, no, that makes sense. So I can even use the ID. But now in order to do that, in order to actually pass that to the function, I need to do the inference of the function contexts. Otherwise, I will not be able to do that. Maybe I just do the old implementation because that's just easy. So it is going to be still the global trait system then. But I will want to redo it still. I just need to think about it a little more, I guess. Fine, I'll just do the old implementation. It's very easy. Implementing traits. I'll just think about it more. But for this implementation is going to be not implemented using the current ones. It's going to be a dedicated thing, right? So we will have a new expression which is called cast, right? So that's the as operator. It's not now going to be the core syntax, not the syntax sugar. So we have the casting expression cast, and expression cast means that I am casting the value, which is an expression. I'm casting it into a target. So what's the target? Target is target is target is the type, right? Target is type. Not necessarily. Target is maybe just any value. That is how I was doing it. So it can be a type or it can be a generic thing. Right? Let's say that target is value. Should this value be known at compile time? It should be known at compile time, yes. Let's try that. We have expression cast. Where did I edit? Like so. You're not calling it cast? No, I'm not calling it cast. It's just like the problem. I'm going to like keep using it, and then when I do a new system, it's going to be maybe, I don't know. Like a lot of code will need to be rewritten. I mean the code that uses that feature. We'll see. Print context, print expression, cast, value, target. This is going to be print fmt. Cast, value, target. Print expression value. Print value, target. expression short, expression cast. Okay, so now in the interpreter, we are going to have the global map. We are going to have the global map. I already have the ability to have maps of values, right? Expression cast value target. So we need to know the implementation here, right? Let me do underscore here. I want to have interpreter state. So interpreter state is going to have the yeah, we have instantiated generics here, and similarly to that we will have trait implementations, or we don't call them traits, right? We call them cast implementations. Cast implementations. And cast implementations is having a mutable map. What we're doing today, I'm implementing traits in my language right now. I solved the advent of code, which was the first part. Traits, casts. Casts is generic. Traits is the specific usage of the casting. So we have a map from we have value map, right? Value map into so like what do we store? Like so the key in the map is going to be basically the trait or the casting target, and the value is going to be cast is not in Rust, not anymore. It was. It's in OCaml now. Since like how long since the rewrite? I don't remember. It's pretty old already. Like a couple months. We have 400 commits in this new rewrite already. How do I go to the like the first commit here? In the command line will probably be easier. And over here plus 500. No, we do plus 400 because we have 400 commit. June, yeah, it was in June. What am I implementing now? The traits, the casts. So that I can have traits. So for every trait, I want to know all of the implementations of that trait. Right? And we can start like I can like start with the simple implementation that I had before, which is where we could only implement the traits for concrete types and not generically. Boom, boom, boom. Generalize and taking generic parameters, as in like generic implementations in Rust. You would write something like this. You know, you have it's like you have a generic structure, right? Struct foo t, which has, you know, field of type t, right? So you want to implement some trait, like for example std fmt debug, right? You want to implement this for foo, but in order to do that, you need to do it generically, right? So for all t's, this is the implementation that itself has the generic argument, right? So that's what I mean. This argument over here is the argument of the implementation itself. Value map. Then I guess we just have another value map here. So for every trait, for every like argument, for every type, we know the result of the casting. That's how I was doing it before. So it's value, value, value. Is that right? Is mutable, which is why it was mismatching. Okay, so okay, fine. So the idea then, but yeah, but when I cut, yeah, okay, yeah, we just do that for now. Sure. Like I kind of like was treating the generics especially here. So like I'm just thinking if I do it a little bit better than last time, at least, if not like completely different. Like I feel like in code I would still want to do trait. Let's go to hello here. So I will want to say something like this, right? What's a trait? So if we just take a look at the previous implementation, then a trait is just this. We have a constant trait, like let's say trait parse, right? Parse to parse the type t, right? So this should be a generic thing, which just has, so this is just a vtable basically, which allows us to parse the type t. So we have the function parse here, which takes string and returns t, right? Which means that this is a generic type itself. So parse is just a generic type, right? And we have a value of type parse t, then this is the vtable, which is the trait implementation of t as parse. And then we would just say that we implement like int32 as parse to be the thing where a parse is you know, like int 32 string to int 32, which is like the native thing, right, for now. So we can just do that, which means that when I'm doing as here, this over here is expected to be a generic thing, and the type here is expected to be basically like this over here. This value on the right side, which is the implementation, is supposed to be of type parse int 32, because that's what we have specified here. And then when we see in code int 32 as parse, we would just basically get this value back, and that's all that we do. But in case of I guess I never implemented casting of the integers themselves, right? So when we say like x is 1 2 3, which is int 32, and then I say x as int 64, I kind of want to like use the same mechanism, right? But in this case, this is not a generic. This is just a concrete type already. So in this case, how do we implement the casting? I feel like we implement like, you know, int 32 as int 64. So in this case, this is a type, and this is the target type. So this is the casting, and this should be basically we have a function which takes the thing, you know. So it's like x into like, you know, actual implementation, which is similar but different. Because what is the type that we are expecting here? And why is it different? It's different because this is a generic and this is a concrete type. It looks the same though, which is a little weird. So we could instead say that int 32, like again, if we say that int 32 as into int 64, that would be like a proper trait, right? But then it means that this needs a different syntax, right? For the actual casting. So in this case, into is a trait, is like generic. You know, this is t, and this is u type dot into is u into t, right? So this is like the actual v table of the trait into t. We convert u into t in this case. So I think it's fine. Maybe like we just have the into trait. Yeah, maybe we just have the into trait. should be like connected to, like, it should be like a special one though, is what that means. But we have the into trait, and then when I'm seeing this and I'm detecting that this is not a generic but a concrete type, then we instead rewrite this. We instead rewrite this automatically into type of X as into int64 dot into X. Right? So this step can be done like separately later. And for now, we can just only implement like this. Yeah. Sure. So okay. We need two things then, right? I only introduced right now the expression cast, but we need to implement the cast, right? Expression cast. We need to have expression cast, and we need to have expression implement the cast. Expression implement the cast. Expression implement cast. And expression implement cast is well, wait, hold on. Is it expression even? I mean, I think it is. It's going to be like similar to the context, but I will want to execute that like immediately, right? Maybe this should not be an expression even, I don't know. So we have we are implementing casting value as target, and which is going to be equal to the implementation, like this, right? There are three expressions. Implement cast value target implementation. Expression value, print expression target, print expression implementation. What's the problem? Yeah, so now we implement this in the interpreter. Okay. Okay, so we have the map, right? We have the map, we have the value, we have the target. Over here, what I'm going to do is I'm going to say that value is evaluate the value. That's the first thing that we do. And then I need to basically find, right, value map. Find opt. I don't have the value map here. What's a value map? Is it types value map? Yeah, I guess type value map. Find opt. So I need to find in the state cast implementations. I need to find the target there, right? So this is target implementations, right? Well, I guess I need to like find the actual implementation. Implementation is this into option, and then function. So this is target implementations. And then we say target implementations, value map find opt. So I need to find the value in the target implementations. That's it, right? So implementation is now the option. Optional value, supposedly. Right? So then we just return the implementation. That's all that it is. But this is optional, right? So we are going to match implementation with with some implementation, then implementation. If none, then we error span no implementation, and we return error third span, right? So okay, and then if we have expression implement cast value target and implementation, then I should do that value is evaluate value, target is evaluate target, implementation is evaluate implementation, and then we just need to mutate this also cast impulse dot map, I guess. So I need to modify the cast implementations, right? Yes, let's say current target implementations is state cast implementations map value map find opt target option unwrap, or else we return the empty map value value map empty. So this is current target implementations in which, so like updated target implementations is types value map. Well, I mean we have update, but I mean we just add current target implementations, we just add value to be equal to implementation, right? And then we just say that state cast implementations map, we state cast implementations map, we value map add target updated target implementations. There we go. That's all that we do here, and then we return value unit span. Okay, I think that this is implemented in the interpreter. This is really easy, right? So next there's other places. When I initialize the interpreter, we don't have any implementations yet, right? So cast implementations is the thing where map is value map empty. Okay, in the compiler. Okay, now in the compiler, the inference. The inference. Do I have expression implement cast? Implement cast. I think I don't. No, I do. I need to like assert that the type is correct here, kind of. Value target implementation. I will have a to do here. Assert implementation type is correct, but for now we just don't do anything, and we infer that the result here is unit, and we have expression cast value and target. So in this case, target is already a value, right? I'm going to match value await inferred, right? So if well, I mean, I don't even need to do that right now. No, I need to do that right now because the type, yeah, I do need the types here, and it means that this over here target also must be value, I think. And the expression, this must be value, I believe. But it means that when I'm implementing this here, this also must be value. And this must be value. Everything is value. Everything is not at compile time right now. Not sure. We don't evaluate the target is already a value here. If I have the cast, we just say that we have the value. The type of this is I mean, I already do the evaluation here for the instantiating generics, I think. Instantiate generic. How do I do here? Argument. We just evaluate this here, yeah. Which means that I could have made it an expression still. Implement cast. Values expression. Well, I mean, that's what I need to do, you know? I need to have a helper function. And have a helper function which is going to be cast result type. This is going to have a value that, so like we have a value and we cast it into the target and we want to know the result type. So for now, these both must be values, right? Or should this be expression? Cast result type. Maybe I do expression here. Value expression. Just have expression, value type. And I guess also state then. Maybe something else. function state value target type new not inferred span. Let's have span here too. So over here then, let's just pretend that this function is implemented. So we have cast result type value target. That's my type, right? And I should say that implementation data type inference type expect inferred as this. And also in this case, the result type is just cast result type value target span state. Right? So it's like really easy like that then. Now, how do I implement this? I need to say that value is I just evaluate this here at compile time for now. And then I and to like make sure that this one is generic, right? So I'm going to match target await inferred, which means that this must be inferred. So yeah, we need to say that type is new not inferred span this thing, and I will return that type, and I will do this thing in a fork then, right? So can we do fork? It's called state scope fork. So we do this in a fork. Await inferred the target error span cannot cast into value shape print other. This should return an error. But if this over here is a value generic, then what do I do? What is the type here? Value generic. We have the untyped function, right? So in this case, I just call this function. And that is my type. Right? So I just do call untyped function. Well, I don't even call it. I just instantiate the generic, right? We'll literally just do instantiation. Why am I even calling it here? Because that's figuring out the type of a generic instantiation. Yeah. Do I have a cast interpreter instantiate? There is instantiating. So instantiate. Yeah, we just know that this is a generic, right? And that's all. So we instantiate span state interpreter. So generic itself is the target, and the value is the value. And that is my result, which in this case must be a type, right? So I'm going to match result expect type. If it is none, then I will error. Generic must be a generic type. Let's just do this for now, and then if we have some type, some result type, then we actually say that type expect inferred as result type. There we go. Is that all? Is that all that I need to do? I have some things in the transpiler, which I'm just going to say to do. So we have a expression implement cast, and we have expression cast, and then we have the LSP, which says if we have expression implement cast, value target implementation, then we say handle expression value, handle expression target, handle expression impl. Although this right now is not a thing. Let's just assert that the type of target is value here for now. In case I change it later, I will remember this way to change this line. Cast value and target. We say handle expression value is target. Okay, so it says success, but I did not have the syntax yet for it, right? So the other thing that we need to do is to do the core syntax. So we need to have core syntax, which is implement cast and cast. Implement cast and cast. Let's see, implement cast is going to be value, and target is children tuple map st child expect est into tuple unwrap unnamed 2. No, unwrap named 2. So we have a name value, and we have name target. Want this to be named. So this must be an expression. Right? Simple cast must be expression. And we create expression implement cast, where value is compile expression value, where target is evaluate okay, let's see, compiler evaluate. We don't know the type though, so we say that type is type new not inferred. Target span. So we evaluate module C AST, which is target, because I need to evaluate the target right now, and this is going to be target and target expression, because I need to say that over here evaluate expressions is target expression, so that we can hover it. And then over here just say target. And now this is also missing the implementation, which is C compile expression implementation. Expression constructor initialize expression. This must be colon. This variant expression is expected to have type a list option. It's going to be this, right? Okay, there we go. Oh wait, this is not implementation. Wait, no, it is implementation. Wait, if it is implementation cast, then I also need to have the implementation here, right? Implementation. We have this and implementation. There we go. Unravel named 3. Okay, and then we have the actual cast, which is very similar. We just have cast, 2. We don't have implementation here. We do that. And then we just say that this is cast, value target, and that's all. Cast must be expression. If it is a place expression though, then we say compiler temporary expression module C AST. And that's all. Now we go to the syntax rules, and we need to implement the syntax. So let's see. Implement this as that would probably be somewhere over here, somewhere similar to the let's implement syntax. Something over here. We have syntax core implement cast. Fab never is implement value as target be equal implementation. And then we have syntax core cast, which is where we just do value as target, which is already we already have. Actually, we just make that this is a core cast. Okay, do you think it's going to work first try? Do you think it's going to work first try? Let's see, const foo is the let's have a thing. You know, the default trait from Rust is just a trait where default is a function returning t, right? That's what we want. So now I want to basically say implement int32 as default to be default is returning 1 2 3, because that's what it is. Cannot find int32, std int32. Okay, so now we say std int32 as default dot default is 1 2 3. Okay, so it just worked, right? But it will not work in generic context, probably, I'm assuming right now. Or is it? Wait, is it? No, it actually will. It actually will work, right? Let's try that. Let's try having the parse, right? So right now I have in my standard library, we have the thing which is called, you know, int30, string to int32 and int to string, right? And the other way, I guess. We want both of them, right? So we want instead to have, can I restart cast language server? We can have syntax highlighting here. So I want to have the trait. Do I put this into like a module or something? Can I say where does it live even? In standard library of Rust. The parse parse trait. Wait, there is no parse trait. There's from string, which is, yeah, so it's in this string thing, right? Well, I guess it makes sense, right? So parsing is from strings and converting to strings is also there, right? Although the display trait is from the FMT. So it's, yeah, I don't know. Maybe so like, should this be part of the string module basically? So string parse and string like into string basically, or like whatever. No, probably FMT, but FMT. What's the toString? So this is still toString, right? But we have the implementation of toString for everything that is display. Yeah. So this still belongs to the string module, which makes sense. Yeah, I guess. Let's go to the string module then, and then we'll say something like this. We'll say that we have a trait parse. Well, I mean parse. Why don't I see the parse anywhere? That makes no sense. Oh, because that's just a method on the string. I see. So parse is for things that implement from string. Yeah, that makes sense. Let's call it the same because I don't know. From string. From string is a trait for type. So this generic argument is the self basically in Rust, right? Type, and this is going to be from string is string into self, right? That's what we want. And we have and we have toString. Yeah, sure. Let's just do this. From string and toString. That makes sense. Self type, which is toString, is self into string. And then we will have the free methods, free functions, which is going to be called parse. So parse is a function that takes, so this is a generic function for t, where t is implementing this trait, but we cannot express that yet. So say t, and we have string, and this returns t, right? So this is going to be implemented as t as from string dot from string s. That's all. And we have a function toString, T, value T. I feel like toString also should probably take a reference, but I'm not sure. Should it take a reference? Let's do it by value for now. Everything is copy at this moment. Value T, return string, and this is just going to be T as toString dot toString value. So we use this, for example, in a guessing number game, right? So in a guessing number game, I would say input prompt into string to int32. But what we want is to put this into the parse function. So should the parse function be part of the prelude? I think it should be, right? So we will use string dot parse, and we will use string dot toString. This is the two functions that I want to re-export from the prelude here. So we just say parse, and this should just work. So parse. Wait, why does it say binding T? This is weird. Why does this say binding T? Hello? Parse, this is a type. Parse, binding T. Did I change my toString implementations? That's not how it worked before, right? STD. I have binding T's everywhere. Since when? Since when is this printing binding T's just instead of just T? I did not change that, did I? No, I didn't. Oh, it's because of pattern. Because when I did yesterday the place expressions, that makes sense. That's when I changed it. Yeah, I probably want to fix this immediately. Binding, print. It's like print because it's we now have pattern. We now have pattern place. Wait, do I still have pattern binding? No, yeah, I do have pattern binding. Print binding. Oh, yeah. Okay, that makes sense. Because, like, I don't want this to be printed here. That makes sense. Sometimes I do, sometimes I don't. Because this also prints refs. Like, this is the debug implementation. When I want to dump the AST, I guess. Yeah, that's why I had two functions previously, right? Maybe I should have like another thing in the options. Let's have this as a separate thing. Print pattern shape, just placeholder is going to be underscore. Unit is this. This should not be reference. This should be reference like this. Then binding should be should just be printing binding. And then tuple should just be a tuple. And variant. And variant should be There should be colon label pattern. Sure, good enough for now. Yes, a number. So the question is, does this work? So now we just say input prompt and we say parse, right? So the type T here is inferred based on the usage, because the type of the thing that I'm guessing is an integer. The reason it's an integer is because picked is an integer. That's the only reason, because I'm generating an int32 here, right? If we say that picked is something else, so picked now is not inferred thing, then guess is also not inferred, right? And we don't know what to parse here at all. So this is going to fail. But if I make this an int64, that will work. Also, I guess. Cast examples, guess a number. So this is not going to work because it's going to say that no implementation. No implementation for not inferred type as parse. Which brings me to the other thing that, like, this should be a different error. I mean, I should be waiting for things to be inferred there. Yeah. But this should still work, because this should know that the type is an integer, right? So if we say guess 5, no, this does not work. Okay, it failed. It says, oh wait, no, this makes sense. There is no implementation because I never introduced the implementation, right? So string ks, I need to say that over here that this trait is implemented, right? Implement int32 as from string to be the thing where from string is basically the int32 to string, which also means that I probably should remove from the standard library the function int32 to string. Right, we'll literally just move that into the implementation of the trait over here. This function s, this is toString. It's different. Implement int32 as toString to be toString is number into that. And int64. I remove all of these things and I move them here. This should be s into string to int32 s. Let's just do immediately the same for int64 in both ways. This now says that while complement place int32 to string. Yeah, so now this is not existing, right? We don't have these functions anymore. We instead use the parse and toString functions, which are generic. Okay, so we guess 5. It still did not work because it said that no implementation. Okay, no implementation. Let's improve the message. No implementation. No implementation of what for what? No implementation of this as that. Right, so there's going to be a value print value print target. Right, can I do that? 5. No implementation of int32 as generic. Yes. That should have worked though, but the reason it did not work, I think I understand, because it was not inferred when I added the implementation. So yeah, when I say implement cast, oh wait, also isn't it because I have a different compiler? Wait. Yes. Wait. Yeah. Wait, hold on. What? Implement cast. Yeah, I actually don't know the implementation itself at compile time. I only start knowing it at interpreter time when this thing is actually evaluated. It is evaluated, yes. Let's just add the log that I have added implementation, right? Value impl, right? Let's do here log info log added cast implementation, and cast implementation this as this is equal to that. Value print value print target value print implementation. Actually, I don't really care about the implementation here. Maybe just do value and target here. I added, yeah, so I added it, right? I added int32, I added int64, and we already know that it's generic, so it should work. So why did it not work when I wanted to find the implementation then? Is it a different... No. What's the problem? Let's go and say... No implementation is found. How about I print all of the current implementations then in this case? Log info log right, I just want to state cast implementations map value map iterate function target implementations height value map iterate function value implementation log info exists implementation this as this value print target print value print target. Let's see. It did not even have any. Oh, it's because it's a different interpreter. Because this one is in the standard library, I think. right? So if this one is in the standard library, it's because of the way I'm implementing the imports, right? So when I'm importing the thing, what am I doing here? So this is a compiler. So it's using the compiler interpreter. So yeah, so this is where I can fix like two things at the same time. So the result of the imported file is not only the value which the file defines, but we also actually have some side effects which are implementing syntax is one thing, and the other thing is implementing the casting. So we have implementations which should also be imported when I'm importing, if I'm importing everything, right? So yeah, import should not give me the value, it should give me something else. So imported, state imported, right? When I have imported, oh wait, oh, hold on, it already have custom syntax implementations, right? So I already did that, which is actually weird then. Why? Maybe like I started working on that then, because I still have this bug. So I have custom syntax implementations. But then I should also have the I should also have the things, you know? I should also have implementations, cast implementations, which is going to be cast implementations. I already have this as a type even. So we say state custom syntax impulse. What is state? State is the state of the, because that's in the compiler. Yeah. And then we say that. Do I actually create a new interpreter here though? What's the state? Import cache interpreter. I use the original interpreter. Wait, I actually use the original interpreter, but the interpreter that I used to compile the thing. Okay. But this also means that this interpreter can use the trait implementations from the original interpreter, which is wrong. So I need to actually create the empty one. Why am I even using the original interpreter? Like, since this is an imported thing, I should create a new interpreter, right? That's weird. Like, why am I using this that one? For some reason. I guess I cannot really like create a new interpreter because new interpreter sometimes means the interpreter that contains the std, and sometimes the interpreter that is not containing the std. If I'm bootstrapping the standard library currently, means that there should be a flag somewhere that I'm bootstrapping the std or not. Which is probably why this is done like that. Let's do this. State interpreter with cast implementations. B map is value map empty. I'm just going to do that. You know, but I want to do a to do here. Should be brand new interpreter. I mean, even the compiler, like, why am I using the same scope here? And compiler? Like, the entire state should be a new one. It was just the import cache is the only thing that I should be saying. Why is the scope the original scope? That makes no sense. Why is this? Can I not just like create a new scope here and test it? It should work. Why is this not a new scope? So when I have imported, I'm just going to say that cast implementations is the state interpreter cast implementations. And over here we say state relations is map is value map empty. Okay, but am I actually using the custom syntax? Oh yes, when I'm importing, I'm adding the these things that are cached. Imported, yeah. We have the import cache, yeah. Something else was not working. Oh yes, something else was not working. Because over here I always create, yeah, whenever I import, I see the problem. Yeah, custom syntax implementations is the is empty one in all of the imported files. That's why I have the bug. So there is another to do here. Should have a impulse from std, I guess, right? Which is how I fixed that one. Okay, but anyway, when I'm actually importing, then I need to add the things to the interpreter. Import a value. But am I using the original interpreter? I feel like this file has a lot of to-dos here. To do what if it's going to be evaluated in a different interpreter, but I'm going to state that C state interpreter past implementations. I will need to merge it, right? Map is C state interpreter custom implementations. Map. I'll need to do like value types, value map, union, merge. If it is a map whose keys are subset in one, the present of each binding. Determine the function f. Merge and there's union. Union is just giving me what if they are both present. Okay. So I'm going to unionize function a, b, some a, I suppose. We just keep the first one for now. We have conflicting implementations, I guess. I mean, I can just report the error here. Error span collecting implementations. And then we do this cast And we also make this to the result dot cast implementations, right? We merge these two things. Cast implementation dot map. This expression should not be a constructor. Wait, why is this having value? A option. What is value here? Oh, because it's a key. Yeah, I don't care about the key here. I guess. Well, I mean, kind of. Wait, no, this is actually wrong. This is not the, yeah, because this is the target. This is target, and then this is implementations for the target in one, and in the other one, in this case, I actually want to union the inner ones, right? So types value map. I want to union impulse A and impulse B using a function. So in this case, we have a function value AB and in this case we say conflicting implementations, and I can even print it, right? Conflicting implementations of cast this as that. So like value print value and value print target. So yeah, I just say that the B is going to be ignored here. Okay, is that going to work? Let's try again. Guess a number. 5. It did not work. Because it still said that there is no implementation. Even though I edited it. Because the interpreter is different after all. The interpreter is different after all. Which means that import should like, how does this even work, right? So we have interpreter without standard library, I guess. Yeah, so like it's because the standard library is evaluated in a different interpreter. We have interpreter without standard library. So we bootstrap. We try to evaluate the standard library. We evaluate the standard library by importing that using the bootstrap compiler, which has the interpreter without the standard library, and then I create a new interpreter using that stuff. So I can just like kind of import this here right now as a hack. Because then I'm just using the same interpreter, right? But that's a kind of a hack. If I did it in a not hacky way, then the import should be a thing with effects of introducing new implementations. Let's just try this. Interpreter with std dot custom implementations map is going to be equal to interpreter without std custom implementations map. To do hack. Five. It still didn't work. Shit. Wait, how many interpreters am I actually creating? Well, let's do this. You know what? How about we do this? We do it in the standard library itself. String ks. Like, can I try using it here? Can I say over here something like dbg print, you know, like parse 1 2 3, or which is supposed to be like an int64, you know? So it's supposed to parse this into an int64 and print it, right, at compile time, just like this. No implementation. Yeah, okay, so it still says that there is no implementation. Now that makes no sense. Even though it exists, right? Like literally at the same time it says that it exists. Did it say that before? No, in this case nothing exists even. But in this case it even exists. Which means what? Maybe it means so ts from string did not work, right? No implementation of this type. Of type in 64 as generic. I think it's because my value map is actually not correct. I'm pretty sure it probably is. Yeah, it probably is. Let me see. Types. It probably is because my value map is not correct. Because value map is just map make value implementation, where I'm comparing by using this compare value function, which is derived, right? So let's say that I have a type, for example, that would be comparing the things, and they are not stable because I have variables there. Maybe. Or wait, no, it's because it's a const there, and these things are. Wait, what? I don't know. Okay, maybe let's improve the printing here. So they just say that int32 as generic. Generic is not very like useful, right? But that's because when I'm printing generic over here, right? When I have a generic value, generic G, I want to at least print its ID, I guess, right? So generic ID print G ID, right? Should have the IDs here. Yes. So I'm trying to find int64 as generic 7498, and it exists in 64 at 7498. This exists. And since that exists, it should be found in the map, but it's not found. So why is it not found if it's literally there? It may be just because the map implementation is not correct, right? So how about I say this, no impl, right? How about I say over here, if types value impl compare, like I want compare. This is value, this is target, but like, yeah, and this is like my original value and target. So let's call this existing target. Let's call this existing value, right? I want to say over here, if value impl compare target, existing target is 0, and types value impl compare value, existing value is 0. Then I want to also print not found, but actually there, you know, something like this. Because if they are equal, then it should be found, right? And they are actually not equal. Okay, so that makes sense now, right? It's because my comparator is incorrect. And the comparator is being derived right now. So why is it not correct? Well, first of all of these things are variables. So I think what's not correct is the implementation of inference variables, whether they're equal or not. So equal variable, compare variable, because this right now is implemented with comparing the recurse IDs. Wait, what? No. Wait, what? This is correct. Well, I guess not really, because this can be, yeah. Yeah, so like, yeah. So even if this is like two different variables, but they can have the same value, still. And like also in general, I'm comparing the variables, right? The variables over time, they change their values. I mean, they don't change their values, but they first did not have the value. And then they started having the values. And so the comparator is going to return a different result potentially, because the recurse ID is changing. This equality also is physical equality of the roots. But if the values are inferred, okay, we like, it's a little weird. Like, I'm not sure if I can do that. It's going to lead to more bugs. It's a little weird. But like, so like equality also, right? Equality also changes over time when I'm merging variables. They were not equal and now they are equal. let's just say then something like this. If they are equal, let's do this, right? If they're equal, then true. Else, I'm going to actually match this is root variable. Wait, root variable, physical equal. What's a variable? But a variable is just this. I mean, yeah, that makes sense. Or I think I should just like for equal also just find the root. And then I'm not doing the physical equal, but I will say that if... I mean, you know what? Let's implement equality using compare. That makes sense, right? So I will just say that compare A and B is equal to 0. How about that? Yo, Lane! Hello. Welcome, raiders. Thank you for the raid. You ended the stream earlier today than usually, I guess. Your turn to raid me. Well, thank you. How's your language going? A lot of progress was done today. So I am like already using my language here to solve the advent of code, and I have solved day 5 already. And right now I'm trying to implement the traits. It's going to be like a very simple implementations of traits for now, where I can only implement the traits for concrete types. I might change the implementation completely later. But not a lane, it's Kalindra. Alright, yeah. Hello. Yeah. Thank you again. You can go rest now, I guess. I'll try to explain what I'm doing in a bit, because I'm almost done here. But basically, I'm trying to. I have like this guessing number game, which I'm trying to make work, right? So we have this like generic parse function, which is implemented just using traits, right? Like this. So we have trait from string, and it has method from string, which we just call when we try to parse something, right? So that's what I'm trying to make, and then there are some issues, some bugs currently. So the bug is that I'm storing my implementations in a map, right, where the keys are basically traits and the types for which I implement the traits. But the thing is, why did it just send me on a raid? Wait, what do you mean? Kuvi, Pigorli? Why did you raid us? What? Did I raid someone? I raided? Oh, wait, what? oh, I see. Oh my god. I understand now what happened. I'm stupid. I thought, okay. I wanted to do a shout out and then typed raid instead. Right? My bad. I just traded back. Okay. So you guys are still here? I meant to do a shout out. This proves Penguin Operator is a bot. What's happening in chat there? Nothing. All right. Well, my bad. So you guys had to manually go back to this stream? All right. Yeah. Nice. Nice. Okay, whatever. Tell me to send when you start read. Yeah, I just didn't understand this. Well, yeah. I just typed it and I yeah. I thought I did a shout out. Okay. Can I read again? Alright, I cancel this time. Because you made no verbal indication of reading yet. Reviewing operator said thanks, yeah, I see. No implementations. I was doing something. Yes, so we just do equal in terms of comparison, and comparison, we say this. If recurse IDs are the same, then we just return 0. Otherwise, I will say that I need... I'm going to match A inferred and B inferred with... Well, I mean, it's not even A inferred, B inferred, right? It should be like option compare using... Well, and now I need to actually compare the values, right? So, which means that this thing is actually generic indeed. Like that. So equal and compare. This should be like equality. Wait, but equal contains equality. I cannot even implement it using comparison then, because that's not how it works. Okay, sure. Shape equal. And this over here is compare shape. Or like equal inferred, I guess. And this is compare inferred. So we're going to option compare inferred, A inferred, B inferred, right? There we go. And then over here we say that we just do the same, but using the equality. Option equal, equal inferred, inferred A, inferred B. In this case we return true, and in this case we do that. But what if the thing is recursive? That means that I need to do it with a recurse cache. Recurse cache with cache. Recurse cache. Create. Implementation equal implementation AB. That does not work because the recurse cache should be done on the other places. This is just going to give me infinite loops, which is why I did not do it originally, I suppose. Well, let's see if it works though. So this should be like compare. No, I was using this in this place because I was just relying on actually variables to be equal, I suppose. Are the labels equal? No, we need to use the same. Inference variable same. Raid was lane just got offline. Yeah, it was a failure on my end. Same. Same. Dot say label same variant. If it's the same, then it pattern matches. That's where it's used. This is like the only thing. Yeah, I guess I could use like equal here. That means that I don't need to do this equal, but equal labels means that A label data. Do I just like do a deriving here? Deriving equal ord, right? Unbound value equals span. It's like, no. Label data. So equal is in this case physical equality, but what about the ordering? You just do ID here. ID IDT, sure. Let's equal label data is AB is ID equal AID BID. Let's compare label data. AB is ID compare AID BID. Equal using equal label data. Compare using compare label data. Inference equal var, inference compare var. Sure. So we just say over here ID is ID generate. It's like the ID can be changed though, is the thing. Is the problem. So when I'm uniting them, I say that ID is IID, right? So like this ID can change over time. Oh wait, it worked. Wait, it worked. First try. Easy. I guessed. Guessing number works now. Okay. So this is like, I feel like all the bugs in this implementation that I probably just introduced are the same as the bugs in my old Rust implementation, but yeah. It works well enough for now, I guess, so that I can at least like write code which uses traits. But then the implementation is going to change, probably. String. Yeah, so we have like toString and parse, right? Also, what else do we do for toStrings? We can also implement boolean toStrings, right? I should like do it for all the types, kind of, right? The toStrings at least. What about from string? Should I be able to parse booleans and like other things? I don't know. What other types do I have? Boolean uint32. I mean, yeah, it's the same thing. Character string. And now that I have the traits, okay, so let me just commit this. This is something that can be committed now, right? Basic casting. So now, how do I actually convert my integer from an integer to an N64, right? So that would be std, like I probably want to have the new thing that is going to be called convert, maybe, you know, convert include convert ks convert. So convert is a module which has the trait into, right, which is into t self, into is self into t, right, like that. It should be type. So now that this works, oh, I know why the language server doesn't work, by the way. No, I don't. Added impl, edit cast impl. So edit cast impl is going to just trace now, and no cast, no impl. Sure, this maybe this over here trace, but this over here is going to be error. mzodef, what's up? What am I doing? I'm making my own programming language. In general, I'm just making my own programming language. And currently working on the trait system. So that I can, in this case specifically, convert the integers. I mean, right now I just want to convert an int32 into int64, for example, right? So we are doing this through a trait, like in Rust programming language, for example. So I implement int32 as into int64. Yeah, I can just do that, right? Probably. So then just into is going to be equal to x, like value into maybe cfg if load window. Where's my syntax highlighting? Hello? Oh, there you go. There it is. So I do this if target name is interpreter, then I say native int32 as int64 value. There we go. Yeah, I think something like this should just, so like I will implement these things natively then. int64 as int32. I mean, I should just have the, this should be done differently though. Because like I need the interpreter should be able to read the types already. So this all could be just a single function. But you know what? Let's actually implement this for now. let's do for now just this stupid implementation here, just like before. We're doing like value to string and then parse. So we convert the value into string and then we parse it back. That's how we parse. That's how we cast. For now. Let's not actually do the native one. this is cursed, but let's see. Use std prelude. Into is not in the prelude, right? So I need to do use std convert into, I guess. So then we do int32 as into int64. No implementation. Okay, so this does not exist actually. Interesting. Why does this not exist? Because I created, because this is 22065, but when I say added cast implementation, let's bring this back to the info level. Let me change the prelude to contain convert into. This is like 22069, right? So why is this a new ID which is completely different here? Well, that's because why? Because I just instantiated generic like differently, right? What if I do it again? Then the ID is still the same. But the ID over there was different. Because instantiated generics is another thing that is lost when I'm going from one compiler to the other, right? Can I say over here dbg print in 123 as int64? That's not going to work. int32 as into int64 into 123, right? So this should be an int 64. What are you? Place is not initialized. What place? dbg is not found. Wait, why is dbg not found here? That's weird. I'm in the convert, so did I say std dbg print? Says cannot find dbg in the scope. This is not dbg, this is std dbg. Hello? Oh, wait, what? Convert lib dbg, because dbg is defined after. It's like, I guess the order here actually matters. Yeah. So await compiled now does not work. I cannot do that here directly. because I'm trying to evaluate this, but this cannot be evaluated because this is not compiled yet. That makes sense, actually. That makes sense. I just need to fork in some more places, I guess. Boom, 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 boom. So I cannot even test it right now. Over here. So I need to have a better map. I need to have a better map. I need to have a better map. Okay, so here's the problem, right? I have so I have like two places where I'm instantiating. So like I'm instantiating generic with one variable a, and I'm instantiating generic in the other place with the variable b, right? But what if a is actually equal to b, right? Because of the inference. Because of the inference, like it can be written differently, right? But the inference is going to unify this later. So we need to have a map which can unify its keys sometimes, right? So like we need to like subscribe to the fact that these variables have been unified, and when that happens, I need to say that my keys in the map are now single key, and I need to like merge the values then also somehow. Right? Yeah. Okay, but I think I will think about that some other time. I think I will think about that some other time. Convert into not working. But we have the basic stuff working. Let me check if it works on the playground now. Maybe like for some reason it doesn't work on the web. Let's just say use std prelude let x int 32 is input parse. Wait, there's no parse yet. That means that it's not compiled yet. GitHub castlang cast. Actions. No, it was done. This is convert into that is not working. Maybe I need to like reload. String parse. Field parse is not there. Yeah. Wait, why is this the old one then? because when we do Control Shift R, it's not like reloading the assets from the other domain still. Is that why? And change something here. So like if I reload here. This over here. Queue started downloaded. This is literally instant, right? 0, because it is cached. It's cached. Can I like uncache it? I mean, it's just the cache on the GitHub pages, right? But because someone on the other domain is like not being cleared properly. Just open the cached script, it should update. Like if I just open it, open in a new tab like this, reload it, and then I go back here. Parse is not there. Oh, yeah, it actually was transferred, right? Weird. Alright, I'll just check later. Boom, 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 boom. Boom, 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 boom.
De Meister.
See you guys next time. Bye. Now the real read, yeah.
Parse with, and we're gonna get our range